Problem 1, a ladder 500 centimeters long is leaning against a building. If the angle between the ground and the ladder is 57 degrees, how far from the wall is the bottom of the ladder? So we're dealing with these right triangle word problems. So at the first step, you really want to draw a right triangle and then try to label what's going on in the problem. Here you're going to have a ladder leaning against a building. So we're going to have the ladder as this diagonal line, the hypotenuse. We're going to have our building on the left, and then it mentions the ground. I think it's always easier to label the picture based with the words. And it says the ladder is 500 centimeters long. So where I see the ladder, I'm going to label that as 500. It says the angle between the ground and the ladder. Well, the ground is along the bottom. The ladder is this diagonal line. So the angle between those is right down here at the bottom. That's going to be 57 degrees. How far from the wall? Well, the wall, I'm going to assume, is this side of the building. You have the wall. How far from the wall is the bottom of the ladder? So the bottom of the ladder is on the ground. The wall is this corner here. So this question is asking you, how long is this bottom side? So that's where my X is going to go. So that's the diagram that we want to use. And step 1 is to label the picture. So the hypotenuse is opposite the right angle, so the 500 is going to be the hypotenuse. Trigonometry is always about the angle. So there's my angle, so the opposite side will be this height, this wall, this building, and then the X is going to be the adjacent. So step 1 is to label the picture. Step 2 is to identify the active sides. Well, here the hypotenuse is an active side because I know that's 500. And here the adjacent is the active side because I'm trying to solve for X. So I'm going to write out my SOHCAHTOA rule and then try to figure out which of the 3 trig functions I'm using based on the active sides. So the hypotenuse is an active side. The adjacent is the active side. So the only trig function that I have both values for is cosine. The cosine of theta, the cosine of the angle, equals adjacent over hypotenuse. So I'm going to have the cosine of the angle, the cosine of 57, that equals the adjacent, which is X, over the hypotenuse, which is 500. So this is the equation that I'm going to use to solve. And since the X is in the numerator, I'm going to put the cosine of 57 over 1 and cross multiply. I'm going to have 1 times X, that's X. That equals 500 times the cosine of 57. It's always better to write the trigonometry part, the cosine part, second. And now on our calculator, we'll just enter in 500 times the cosine of 57. So how far is the ladder from the wall? We're finding a side of the triangle, so we always round to the nearest tenth. So the 1 is going to keep the 3 the same. So here we're going to have 272.3. Problem 2, the sides of a rectangle. So I'll draw my rectangle. The sides are 25 and 8. So I'll label the longer side as 25 and the shorter side is 8. What is the measure to the nearest degree, the angle formed by the short side and the diagonal of the rectangle? Well, here's the short side. We're going to form a diagonal of the rectangle. So it says, what is the angle formed by this short side and the diagonal? So this angle right there. So here I have 2 right triangles, and what I'm going to do is I'm going to use this red upside down triangle. So I'll redraw that over here. Now, what do I know about this red upside down triangle? Well, I'm trying to solve for x. I know this side is 8. I know I have a rectangle, so I have 4 right angles. But I'm also going to know this top side is going to be 25 because opposite sides of a rectangle are equal or congruent. So this is the diagram that I'm going to use to solve this problem. So step 1 is to label the picture. So here's my right angle, so I'll go opposite that. That's the hypotenuse. Trigonometry is always about the angles. Well, in this case, I'm trying to solve for that angle x. So directly opposite angle x, I'll label the 25 as the opposite, and then the 8 is the adjacent. So step 1 is to label the picture. Step 2 is to identify the active sides. Well, here my active sides are the opposite, which is 25, and the adjacent, which is 8. So I'll write out SOHCAHTOA, and I'll try to figure out which of the 3 trig functions I'm using here. The active sides are the opposite, the adjacent, so the only trig function that I have both parts for is tangent. So tangent of theta, tangent of the angle, equals opposite over adjacent. So the tangent of theta, the tangent of the angle, well, here the angle is x, so I have the tangent of x equals the opposite, which is 25, over the adjacent, which is 8. So this is the equation that I'm going to use to solve. Here I'm finding an angle. So when you find an angle, you go about pushing buttons to get your answer. So the first button you always press when you're finding an angle is the second button. So I press second and then tangent. Remember, when you're finding an angle, you always want to see that -1, that inverse notation. You enter in your fraction using the alpha y equals menu. Make sure you always close the parentheses. Very, very important that you close the parentheses. And then second, and then apps. And then go to option 4 for DMS, degrees, minutes, seconds. Anytime you're finding an angle, you calculate the angle on your calculator. So you get 72 degrees, 15 minutes, 19.182 seconds. You always look at the seconds, and if it's 30 or more, you round up. If it's less than 30, you stay the same. Well, here 19 is less than 30, so it's going to stay the same. So here our angle, 72 degrees and 15 minutes. Even though these directions sometimes will say find the angle to the nearest degree, anytime we find angles, we're always going to round to the nearest minute. Sides of a triangle, we always go to the nearest tenth. Angles to the nearest minute. Problem 3. A kite is flying 115 feet above the ground. I'm going to start off my right triangle. And I have my kite. So here the kite is going to be at this high point. I have the ground. So I have the ground and the kite. And the kite is 115 feet above the ground. So I'm going to label this height as 115. The length of the string to the kite is 150 feet. So you have to imagine here, you're flying the kite, and here's the string leading up to the kite. And it says the length of the string is 150 feet. So this diagonal line, the hypotenuse, is going to be 150 feet. Find the angle that the string makes with the ground. So between the string and the ground, the angle is right there. So there's the picture that we're going to use to solve this one. Step 1 is to label the picture, which we already started by labeling the hypotenuse as 150. Trigonometry is always about the angle. So here the angle is x. So I'm going to draw a line directly to the opposite side. So label the 115 as the opposite. And then the bottom, the ground, is going to be the adjacent. So step 1, label the picture. Step 2, identify the active sides. Here the active sides are the opposite and the hypotenuse. So I'm going to write out SOHCAHTOA and try to figure out which of the three trig functions I have the information to use. My active sides are the opposite, the O's, the hypotenuse, the H's, and here the only trig function that I have both parts for is the sine. So I'll write out the rule: the sine of theta, the sine of an angle, equals opposite over hypotenuse. And I'll substitute in the sine of theta. Well, the angle is theta, and here we're trying to solve for the angle, so the sine of x equals the opposite, 115, over the hypotenuse, 150. So sine x equals 115 over 150. I'm finding an angle, which means I'm going to be pushing buttons to get my solution. And remember, when you're finding an angle, you always press the second button first. So here's what your calculator should look like. Remember, you press the second button first. Anytime you're finding an angle, you should see this -1, this inverse sign notation. Make sure you enter your fraction and then close the parentheses. And then anytime you're finding an angle, you always must DMS your answer, degrees, minutes, and seconds. So here you should get 50 degrees, 3 minutes, 19.781 seconds. And you always look at your seconds. If it's 30 or more, you round up. If it's less than 30, it stays the same. Well, 19 is less than 30, so it's going to stay the same. So here our answer is 50 degrees and 3 minutes. Problem 4, an observation tower is 75 meters high. So I'll draw my right triangle, and it mentions the height. So I'm going to have my tower, and it's 75 meters tall, so there's going to be my 75. I have a support wire attached to the tower, so I'm going to have my ground along the bottom, and I have this wire that's going from the ground to the tower. Now it says a support wire is attached to the tower 20 meters from the top. So is this how my diagram is going to be drawn? And the answer is no. If you draw your wire going to the top of the tower, the wire is 75 meters high. But it says the support wire is attached to the tower 20 meters from the top. So this wire that I have is not going to go all the way to the top. The wire is going to go to a point 20 meters from the top. Well, since I know the entire tower is 75, and I'm drawing this wire 20 feet from the top, the wire is going to go 75 minus 20, or 55 meters to the top. So this bottom portion, this height of the wire, this is going to be 55. It says if the support wire and the ground form an angle of 46 degrees. So here's my wire. It says the angle from the wire to the ground is 46 degrees. What is the length of the wire? So I'm going to be putting my X where the wire is. So this triangle right here is going to be the triangle that I'm going to use. And sometimes when you label your picture, it gets so involved, you're better off redrawing it. Here I have my right angle. I know this height of this triangle is going to be 55. I know the angle is going to be 46, and there is my X. So now I'm going to label the picture by my right angle, so X is going to be the hypotenuse. Trigonometry is always about angles. So here my angle is 46, so the opposite is going to be 55, and the adjacent is going to be along the bottom. So step 1 is to label the picture. Step 2, identify the active sides. Well, here, the active sides are going to be the opposite, which is 55, and the hypotenuse, which is what I'm solving for. So I'll write out SOHCAHTOA and try to figure out which of the three I'm using. My active sides are the O's, the opposite, and the hypotenuse I'm solving, so that's the H. So here I'm going to be using sine. The sine of the angle, the sine of theta, equals opposite over hypotenuse. So the sine of the angle, the sine of 46, equals the opposite, that's 55, over the hypotenuse, that's x. So here's the equation that I'm going to be using. Sine of 46 equals 55 over x. And since my x is in the denominator, I'm going to be using that switcheroo rule. I'm going to be taking the sine of 46 and the x and just switching them. So I'm going to have x equals 55 over the sine of 46. I just take the x, I take the sine of 46, and they just switch places. So I'm going to type this in on my calculator, 55 over the sine of 46. I'm finding a side of the triangle, so I'm going to round to the nearest tenth. So that 5 is going to kick the 4 up to 5. So I get 76.5. Problem 5. At a point 50 feet from the base of a tree. So I'll draw my diagram. Hopefully the tree is going straight up in the air, so this height is going to be the tree. And you have a point from the base of the tree. Well, the base is the bottom, so the base of the tree is the corner by the right angle. So you have a point that's 30 feet from the base. It says from this point, the angle formed with the ground is 53 degrees. So my ground's going to be along the bottom. It says an angle formed with the ground looking up to the top. So you have to imagine a person standing here, they're looking up to the top. So the angle formed by the ground and looking up to the top. So this angle along the bottom is 53 degrees. It says find to the nearest foot the height of the tree. So my height, my tree, is going to be my x. So I have my diagram. Sometimes it's best when you label it to redraw it, so that way all the words disappear and you just have the math. So here's my diagram. I'll label the picture for step 1. So I label the hypotenuse. Trigonometry is always about the angle. So here the angle is 53, so the x is going to be opposite, and then this 30 is going to be adjacent. So step 1 is to label the picture. Step 2, identify the active sides. Well, here the 30 is going to be an active side. That's the adjacent. The opposite, what I'm solving for, is x. So here my active sides are opposite and adjacent. I'll write out SOHCAHTOA and try to figure out which of the three I'm using based on these active sides. So the active sides are the O's and the A's. So this one's going to be a tangent problem. The tangent of the angle, the tangent of theta, equals opposite over adjacent. So I have the tangent of theta, the tangent of the angle. The angle is 53. That equals the opposite, which is x, over the adjacent, which is 30. So this is the equation that I'm using to solve. And since my x is in the numerator, I'll put the tangent of 53 over 1 and cross multiply. So I have 1 times x, which is x. That equals 30 times the tangent of 53. And it's always best to write the trigonometry part second. So I'm going to write 30 times the tangent of 53. And then we're going to enter this into our calculator. We're finding a side of the triangle, so we're going to round to the nearest tenth. So this 1 is going to keep the 8 as is. So here our answer, 39.8. 8. Problem 6. An observer is 120 feet from the base of a television tower. So I'm going to have my tower. I'm going to have the ground. And you have an observer that's 120 feet from the base of the tower. So the base of the tower is the bottom, so the base is here. You have the observer, a person is standing here, 120 feet from the base. So this bottom is going to be 120. It says an observer is 120 feet from the base of a television tower, and the tower is 150 feet tall. So I'll label by the tower the 150. Find to the nearest, even though it says degree, anytime we find an angle, it's always to the nearest minute. Find to the nearest minute the angle of elevation. So the angle of elevation is this bottom angle. So here's the diagram that we're using in this problem. Our angle is x. I have 120 along the ground and 150 up top. So step 1 is to label the picture. So I have my right angle. I'll go across, label the hypotenuse. Trigonometry is always about angles. So in this case, the angle is x. So it looks like the 50 is going to be the opposite. And then that makes the 120 the adjacent. The 150 is the opposite. Our active sides are the opposite, 150, and the adjacent, 120. So I'll write out SOHCAHTOA and try to determine, based on these active sides, which of the three I'm using. My active side is the opposite, so I'll label the O's. The adjacent, I'll label the A's. So this is going to be an example of a tangent problem, because I have the opposite and the adjacent. I know the tangent of the angle, the tangent of theta, equals opposite over adjacent. And I substitute in the tangent of theta. Well, the angle here is x. I'm trying to solve for that. So the tangent of x equals the opposite, which is 150, over the adjacent, which is 120. I'm finding an angle, which means I'm going to be pushing buttons on the calculator. And the first button you always press when you're finding an angle is the second button. When you're finding an angle, you always want to press the second button, and you always want to see this inverse notation. Make sure you close your parentheses, and you always have to DMS, degrees, minutes, and seconds, your answer. (51°, 20 minutes, 24.69, and there's more seconds. We always look at the seconds. If it's less than 30, it stays the same. If it's bigger than 30, we round up. Well, 24 is less than 30, so this is going to stay the same. So our answer is 51°, 20 minutes. Number 7, the angle of elevation to the top of a flagpole. So I'll draw my diagram. The flagpole is going to be this height, this vertical line. And the angle of elevation is always along the bottom. So here my angle of elevation to the top of a flagpole from a point on the ground. So I'm going to have my ground along the bottom. And we have the point along the ground. It says 30 meters from the base of the flagpole. Well, the base is the bottom. So the point on the ground is 30 meters. So I'm going to label 30 along the bottom. And it says the angle of elevation is 18°. So actually, that's not going to be my x. That's going to be 18°. What is the height of the flagpole? See, I knew I couldn't have had an x for the angle of elevation because the question is asking you for the height of the flagpole, and that's always your x. So this is the diagram that I'm using. I cleaned it up so we can do some math. So I'm first going to label the picture. So my right angle, always opposite that is the hypotenuse. Trigonometry is always about the angle. So in this case, the angle is 18. So directly opposite that is going to be x. That's going to be our opposite. And then the 30 is going to be the adjacent. Our active sides are going to be the opposite and the adjacent. So I'll write out my SOHCAHTOA and label the active sides. Opposite, so the O's. Adjacent, the A's. This one's going to be a tangent problem. I'll write out my rule. Tangent of the angle, tangent of theta, equals opposite over adjacent. So the tangent of theta, the tangent of the angle is 18, so the tangent of 18 equals opposite, which is x, over adjacent, which is 30. So here's the equation that I'm using. I'm solving for a side. X is in the numerator, so I'll put the tangent of 18 over 1 and cross multiply. So I have 1 times x, which is x. That equals 30 times the tangent of 18. And it's always best to write the trig part second. So I'm writing 30 times the tangent of 18 and not tangent of 18 times 30. I'm going to type this directly into my calculator. I'm finding a side of the triangle, so I'm rounding to the nearest tenth. So this 4 is going to keep the 7 as is. So here my answer is going to be 9.7. Problem 8, from the top of a lighthouse 160 feet high. So we have our lighthouse 160 feet high. The angle of depression. Now, the angle of depression officially is the angle that's formed from the top of something looking directly parallel out above the ground. So this angle right here is the angle of depression. But mathematically, that's the same as the angle of elevation because those are alternate interior angles. And you were taught when parallel lines are cut by a transversal, alternate interior angles are congruent. So anytime you are given the angle of depression, you can label that as the angle of elevation instead, so it stays in your triangle. So it says the angle of depression, the angle of elevation is 24 degrees. So I'll label it in my triangle as 24. It says the top of a lighthouse 160 feet high. So I know the height of the lighthouse is 160 feet. Find to the nearest foot the distance from the boat to the foot of the lighthouse. Well, there's the foot of the lighthouse, and you're going to have your boat that's out at sea. So I'm going to have the sea out here, the water. I have my lighthouse. I have the angle, and here's where the boat is. It says find to the nearest foot the distance from the boat to the foot of the lighthouse. So here is going to be where my X is. And I'm going to redraw the diagram so that it's a little bit neater. So I'm going to have 160 as the height, X is the bottom, and 24 is the angle. So step 1 is to label the picture. So my right angle, directly opposite is the hypotenuse. Trigonometry is always about the angle, so in this case the angle is 24. So I draw a line directly opposite to the 160, and that would make the adjacent X. So step 1 is to label the picture. Step 2 is to identify the active sides. Well, here my active sides are 160 as the opposite, and X is the adjacent. So I'll write out my SOHCAHTOA and determine which of the 3 trig functions I'm using based on these active sides. I label the opposites, the adjacents, And this one is going to be an example of a tangent problem. So I'm going to write out the rule. The tangent of theta, the tangent of the angle, equals opposite over adjacent. So the tangent of theta, the tangent of the angle, so the angle is 24. That equals the opposite, which is 160, over the adjacent, which is x. So this is the equation that I'm using to solve. Tangent of 24 equals 160 over x. X is in the denominator, so I'm going to be using that switcheroo rule. I'm going to take the x and the tangent of 24, and I'm going to be switching them up. Remember, you use the switcheroo rule when your x is in the denominator. So here I'm going to now have x equals 160 over the tangent of 24. So x and tangent of 24, switch places. And now I'm going to type this in directly as I see. 160 over the tangent of 24. Since I'm finding a side of the triangle, I'm going to round to the nearest tenth. So the 6 is going to kick the 3 up to 4. So 359.4.